All right, today we are starting section 7.3. Our objective is to use the angle-angle postulate. Okay, you might notice some similarities between the chapter that we did on congruence and this chapter on similarity. So far we've talked about similarity with polygons. We had to know two things. We had to know that all of the corresponding angles were congruent and that all of the corresponding sides were proportional. Okay, so now we're going to learn some shortcuts. So today we're going to talk about the angle-angle postulate. So it's a shortcut to knowing that two triangles are similar. Our warm-ups today are a throwback to Algebra 1. Let's get those copied down, maybe get started on those, and we will talk about them together in just a minute. All right, so we had all those warm-ups. We did them together on the board, so we will move on to our notes for today. So today we are focusing on the AA postulate. It states that if two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. So I will fill in this diagram down here. So for example, if we were to know that triangles A and D were congruent, and we knew that triangles C and F were congruent, that would be enough for us to know that triangle ABC is similar to triangle DEF. So notice with the angle-angle postulate for similarity, we don't know anything about the side lengths when we start. Okay, all we have to know is that we have two pairs of congruent angles, and then we know that the triangles are similar. Don't confuse this with congruence. We don't know that the triangles are congruent to each other. Just that they are similar. All right. Let's practice using this. So let's get this diagram copied down. We've got a triangle ABC, another triangle DEF. We have a couple angles marked in each of them. We have to decide if there's enough information to know that the triangles are similar. If they are, we will write a similarity statement. If they are not, we will not write a similarity statement. So just from the information they give us, do we have a pair of congruent angles?
Yes.
Yes, which pair?
Angle B and angle E.
Good. We've got two of them that are marked as 80 degrees, so those two are definitely congruent to each other. Are the other two congruent to each other that are marked? No, right? We've got 63 and 27. But we don't have angles C and D labeled yet.
Right.
Is there a way that I could figure out what angle C equals?
Yeah.
Subtraction. So I heard somebody else say 180. Somebody else was saying subtraction. So we take 180 and we subtract off the two angles that we know.
37 degrees.
That gives us the remaining angle, which David said is 37 degrees. We can do the same thing for the other triangle, just to be sure we're not missing anything here. If we take 180 minus 80 minus 27, what do we get? 73 degrees. Okay, so now, are we going to have any other pairs of congruent angles? No. So are the triangles going to be similar? No. So we would say not similar. If we were asked to explain, we would say not all corresponding angles are congruent. So just because we have one pair of them does not work. We need two pairs of them for angle-angle postulate. Yes? All right, number 2. Same question. Must the triangles be similar? If so, write a similarity statement. So this time we have triangle RST and triangle MNP. Does anybody remember what types of triangles these are? Very good. They are isosceles triangles because they have two sides marked congruent. There's a property of isosceles triangles that we learned. So that these two sides are congruent, and also what else is congruent? The angles across from those sides are congruent to each other. So even though they've only given us one angle so far, we can figure out what the other two are. We can take 180 minus 36. What does that give us? 144. Okay, so all together these two angles have to be 144, but they have to be the same. So I would take 144 and divide it by 2.
72 degrees each.
So that gives me 72 degrees each. 72 degrees, 72 degrees. Wonderful. All right, so then I go to my other triangle. Again, it's isosceles. So angle N is going to be congruent to which other angle? P. The angles across from those sides are congruent to each other. So angle P is also 72 degrees. Do we need to find angle M? No, because we've already got two pairs of congruent angles. Angle S is congruent to which angle in the other one? N, really it's congruent to both those other ones, right? And then angle T is congruent to P. Now, it will come out to be true that R and M are also congruent, but we don't need to show that because we just need two pairs of congruent angles to show that they are similar. So because they're similar, we have to write a similarity statement. So triangle, how do we want to name the first one? RST, that works for me, is similar to triangle MNP. Now, if you wanted to name the first triangle differently, you would have to name the second one differently. So another option would be something like triangle SRT is similar to triangle, what order would we have to go in there? NMP. Okay, so we have options. There's more than one correct answer. You just have to have one of them. Does anyone remember what these little arrows on our lines mean? They're parallel. Sometimes we saw them written more as like triangles instead of just little arrows. So those two lines are parallel. Now when they're talking about the two triangles that must be similar, they're talking about the small triangle ADE and the bigger triangle ABC. Those are the two triangles they're talking about. So for this problem, we have to remember our properties of parallel lines. So for this problem, I'm going to kind of take away different pieces of the problem for us to look at it. So if I just take away this side over here for now, we'll bring it back in a minute. And I extend this side here, and I extend my parallel lines. What do I know about the relationship between this angle here at point D and this angle down here at point B? They're on the same side. They're not both exterior though. Down here at B, I'm interior. Corresponding. Very good. They're on the same side and they're both above the parallel line. So they are corresponding. What do we know about corresponding angles on parallel lines? Who thinks congruent? I should see a lot more than 4.5 hands being raised right now. Those angles are congruent to each other. Okay, corresponding angles on parallel lines are congruent. So let's bring that back. So these are going to be congruent to each other. We could do the same thing on the other side. We could take this away for now and focus just on this line and our parallel lines. What's going to be the relationship at point E and at point C? They're again corresponding angles here, which means they are again congruent to each other. So this angle here, AED, is congruent to angle ACB. Now if you need to, you can draw your two triangles separated from each other. ADE, and the bigger triangle was ABC. Okay, so I just drew them separated from each other. Do we have enough information to say that those two triangles are similar? Yes, we can use the angle-angle similarity. Okay, so we would say that triangle, how do you want to name the first one? Whoa, what do we want to call it? BAC, sure. So the big one we're calling BAC, so the small one we have to call DAE. Again, not the only possible answer, but that one works. So for this diagram, we've got two triangles that meet at point C in the middle. We have a few different sides labeled. All the sides in ABC are labeled with one angle labeled. In triangle CED, we've got one side labeled and two angles labeled. The first part of question 4 asks for the measure of angle ACB. Remember, when we name with 3 letters, we start at the first one, A, go to our vertex at C, and then out to B. So we're talking about this angle in here, ACB. What is that angle going to equal? Somebody said 41 degrees. How do you know that? Very good. Vertical angles are congruent. Angle ACB is vertical to that angle at 41 degrees. We are also asked to find the measure of angle B. How can we do that? So B is up here. How can we find B? This goes back to like what we were doing in the first couple examples. How did we find missing angles, Jaden? 180 minus 56 minus what else? 41. We got to subtract off both of those other angles. And what do we get for the measure of angle B? (180 minus 56 minus 41). 83. I agree with that. All right, we have to also find the measure of angle E. How are we going to do that? (180 minus 41 minus 83). we get 56. So angle E is 56 degrees. Are the triangles similar? Yes, right? We actually have shown that all three pairs are congruent to each other. So yes, they are similar by the angle-angle similarity postulate. Angle B was congruent to angle D, and angle E was congruent to angle A. All right, so we are asked to find the measure of side CD. If we know that two triangles are similar, we know that their sides are not similar, not congruent, proportional. Okay, so we're trying to find CD down here. CD is between the 41 degrees and the 83 degrees. So I'm going to label that side X. Over what side in the other triangle is between 41 degrees and 83 degrees? BC, which has a length of 10. So we set that equal to, we need to come up with another pair of sides that we know both of them. So if we start back at the same triangle we started in, we know this side over here is 12. And it would match up with what side in the other triangle? 8. Now we cross multiply and solve. When we cross multiply, what do we get? 8x equals 120. How do we get x by itself? Divide by 8, so x equals 15. All right, we are going to stop there, and we will talk about number 5 tomorrow.